So we've been writing linear functions in slope-intercept form. And now in this section, we're going to practice writing linear functions in point-slope form. Sometimes we'll be given the slope of the function along with the function evaluated at one point. And in the next section, we're actually going to be given no slope. We're just going to be given the function evaluated at 2 points. Either way, we already know how to do this because we've done it with slope-intercept form. In this video, we're going to practice doing so with point-slope form. Now remember, we're making the transition from our y equals, we're going to using our f of x, our functional notation. Remember, these two terms are interchangeable, so let's go ahead and write our point-slope form in functional notation. So we have f of x minus f of x naught equals our slope m times x minus x naught. Okay, you recall our point-slope form, all we did is simply substitute our functional notation everywhere we have y. Okay, so let's use this and write a few linear functions in point-slope form. So let's say we have a function somewhere out in the world, and the slope of this linear function is minus 3, m minus 3. And we also know that f of 1, our function evaluated at x equals 1, equals 6. Now here we're given a slope and 1 point on the line. We can handle functional notation the same way as we have been. We have a slope of minus 3 and we have the point 1, 6. Okay, so x equals 1, and when x equals 1, our function equals 6. So let's go ahead and put these into our point-slope form. So we have f of x minus f of x naught, which is 6, equals our slope, which is minus 3, times x minus x naught, which is just 1. We always write it one time in parentheses whenever we're substituting into an equation or a function, and then we evaluate it. F of x minus 6 equals minus 3, and here there's nothing fancy to it because we're not subtracting negatives or anything like that. So we just simply have f of x minus 6 equals minus 3 times x minus 1. And that is our linear function in point-slope form. Notice that we just replaced each y with f of x, and we replaced y naught, which you probably realize this, with f of x naught. Excuse me. So let's do a few more examples of this. It's pretty straightforward. We've been dealing with point-slope form for quite a while now. We're just making the transition to functional notation. So let's say we have the following function. It has a slope of 1/2, and we have f of 0 equals 5 over 3. And we want to write this function in point-slope form. Well, we know that we have the point 0, 5 over 3. Our function goes through this point, and it has this slope. So we can write this in point-slope form. So we have f of x minus f of x naught, which is 5 over 3, equals our slope, which is 1/2, times x minus x naught, which is 0. And we can just drop our parentheses in this one as well. F of x minus 5 over 3 equals 1/2. Well, this is just 1/2 x. Okay, so if we distribute this 1/2 into the parentheses, we'll see that we have a 0 term. So we can just write 1/2 x on the right. Okay, and that's our linear function in point-slope form. Let's do a couple more just to get a little more practice. Let's say our function has a slope of 8.5, and we're told that f of 2 equals 12. All right, let's go ahead and write out our point. Our function passes through the point 2, 12, and let's go ahead and rewrite our slope in fractional form. I'd rather deal with fractions than decimals. So this will be 17 over 2 for our slope. So let's go and plug these into our point-slope form. Point-slope form is f of x minus f of x naught, which is 12, equals our slope is 17 over 2 times x minus x naught, which is just 2. Here we can evaluate our parentheses. So we have f of x minus, well, this is just 12, equals 17 over 2 times x and just minus 2. And this is our linear equation in point-slope form. Not a whole lot to it. Let's go ahead and look at one more before moving on. Let's say we're given the function with a slope of, or we want to find the function with a slope of minus 4, that our function is evaluated at minus 1, so f of minus 1 equals 9 over 5. Okay, so we have a little bit more work going on in this one. Let's go ahead and identify our point. So our function passes through the point minus 1, 9 over 5, and with a slope of minus 4. So let's go ahead and plug these into our point-slope form. We have f of x minus f of x naught, which is 9 over 5, equals, our slope is minus 4 times x minus x naught, which is just minus 1. And we'll finish it up by writing f of x, drop the parentheses here, minus 9 over 5 equals minus 4 times x. We can cancel these two negatives, so we have x plus 1. And that's all there is to it. Okay, so we should be pretty familiar with working with point-slope form by now. We just wanted to go through a few examples of a little practice of using our functional notation. But this is really the only change. Everything on the right side of our point-slope form is going to stay the same, but on the left side, we're simply replacing y with f of x and y naught with f of x naught. Okay, so that's really the only difference, and our answer, our final functional form in point-slope form, is going to have f of x instead of y. Okay, this is actually really useful because it's actually more it's more defined. It's less ambiguous of what we're actually solving for, where we're plugging in our x values. That our x value is actually the independent variable. So let's look at these a few more times. We'll do some more in the next section where we're not given a slope, but we are given two evaluations of the function. So I'll see you soon.